Hello, in this lecture we're going to talk about some advanced functions such as function templating. So let's get right into it. So one thing we're going to talk about first are default arguments. A function is often called repeatedly with the same value for a particular parameter. We can indicate that a parameter has a default value to be passed, so when a program omits an argument for a parameter with a default argument, the compiler rewrites the function call and inserts the default value of that argument. Default arguments must be the rightmost trailing arguments in a function's parameter list. When calling a function with two or more default arguments, if an omitted argument is not the rightmost argument, then all arguments to the right of that argument must also be omitted. Default arguments must be specified with the first occurrence of the function, namely typically in the function prototype. They can be any expression including constants, global functions, or function calls, and they can also be used with inline functions. So here's an example. We define the function box volume. It has defaults of length equals 1, width equals 1, and height equals 1. If you call it with no arguments, it will call it as if you passed in 1, 1, 1. If you just specify the length, it will set 1 and 1 as the width and height. Similarly, if you set the length and width, it will default to height, and if you specify all, it defaults nothing. So that covers that. That's pretty straightforward. C++ also provides a unary scope resolution operator to access a global variable when a local variable with the same name is in scope. It's a scope override. Using the unary scope resolution operator with a given variable name is optional when the only variable of that name is global. So basically, if you don't have anything overriding the old variable, then you don't need the scope operator because it'll go to the global scope anyway. But otherwise, you can say, like here we define number as a global variable. Here we define number as a double. Here, if we print double, it's going to print the double and a version of it because it's local. Here, if we do this and use the resolution operator, it'll go to the global. So now we're going to get into the basics of function overloading. Function overloading is pretty straightforward. It's what's called syntactic sugar. C++ enables several functions of the same name to be defined if they have different signatures. So this is called function overloading, and it's good for semantic cleanliness. The C++ compiler knows how to select the appropriate function call by examining the number, type, and order of the arguments. Function overloading creates several functions of the same name that perform similar tasks but on different data types. So here, for example, we have square, which is defined in an integer. We have square, which is defined in a double. C++ is smart enough to know how to pick the appropriate version. It looks for one that matches int. Now, the compiler differentiates among overloaded functions by their signatures. The signature is a combination of a function's name and its parameter type in order. The compiler encodes each function identifier with the types of its parameters to ensure type-safe linkage. In other words, so that the right types match. Here are some examples of name mangling. Name mangling is the way the compiler rewrites functions to make them unique. And you don't need to understand how the mangling is done, just that the concept exists. And each compiler may do name mangling differently, too. Return types aren't part of the mangled name, and return types aren't part of the variance for overloaded functions. Two functions that only vary by return types will not compile correctly. So let's take this a step further. What if we have some code where the program logic is identical, but only the type changes? For this, we use something called a function template. And basically what we do is we write a single function definition, and we essentially pass in the type as a parameter. Okay? C++ will automatically generate separate function templates based on that. And here's a sample function template. We define the template name. We use the template keyword, and in it we have the word type name and then T, where T is an arbitrary type. So we say maximum returns type T. It takes a value of 3 values of type T. And now we're going to create a new variable maximum value, which we assume is initially the first value. Here, but it's of type T. We don't know the type. We don't need to. That's the thing. So we switch variables as needed. If value 2 is greater than the maximum value, then it becomes a maximum value. Similarly, value 3 and return maximum value. All of this is done without specifying a type. So all function template definitions begin with the template keyword, then a template parameter list enclosed in angle brackets. You can't have more than one. Each parameter in a template parameter list is preceded by a type name or the word type name or class. And that's for class templates. The type parameters are placeholders for fundamental types or user-defined types. Traditionally, T is used for your first type. It's used to specify the type of the function's parameter at runtime. So the code below is going to demonstrate how to use that function template to determine the value of 3 integers and the largest of 3 doubles and 3 characters, respectively. Behind the scenes, separate functions are created as a result of the calls, expecting 3 int values, 3 double values, and 3 character values. It all happens behind the scenes, but here we go. Here we input our integers, and it says the maximum is maximum int 1, int 2, and 3. Similarly, double, we call it with double 1, 2, and 3, and char 1, 2, and 3. It's very straightforward. The syntax can get a little icky, but beyond that, that's all you got to do to create truly templatized functions.